Hello, everyone. Jorge here with Avalos Cloud Native and Nexus Technologies, a place for you to learn cybersecurity, smart contracts, blockchain, AI, and to find a community of open-minded people who just wants to develop applications, improve their skills, developing new technologies, because we also do that, and to play with a lot open source tools. And not just that, for you to share your creations, your makings, and to never be alone. Because when you're working in tech, you spend a lot of time sitting or standing, and sometimes you have no one to relate to, even at work. It happens to me. So, again, today's video, it will be related to blockchain technologies, specifically the Hyperledger, which is a framework developed by IBM, Fujitsu, and few other companies for centralized blockchain technologies. So let's get started. I have a playlist here for Hyperledger, I believe. Let me see Hyperledger. Oh, it is probably here on the blockchain, but I think I have one for Hyperledger. So this video will go here on the blockchain topics, okay? So I just made a video talking about blockchain smart contracts, and this one will be dedicated to the Hyperledger. Today's topic is about talking about the peers, okay? So we know that the blockchain, right, is composed of components, right? Components are computers, right? Sometimes. And these computers sometimes, whether they're containers or a virtual machine, or maybe a computer or a container in the public cloud, maybe home, maybe my cell phone, right? Because there's many ways of being a peer or a validator, depending on the blockchain that you're working on or the rollup. So let's talk about peers. So peers, let's say that I want to make a blockchain for Canadians. So then I want my blockchain to be talking to each computer, anyone in Canada, whether you're a business or a computer or a person, individual. I want you to have a peer at home, a computer. This computer basically, I didn't get the hardware from anybody. I just bought it. I choose a hardware to support my operating system, my OS, whatever I want, right? Open source, and a box, a computer that will support my packages for my blockchain network, right? For the encryption and all that security. So it means that we're not dependent on the government. We're not dependent on VMware. We're not dependent on IBM. We're not dependent on Dell or Lenovo or HP, right? So we just choose any hardware. That's why we make our applications to be cloud agnostic. Now you're learning other terminologies, increasing your vocabulary when it comes to technology, which I like it. I learn a lot. It helps me to practice and just rephrase my concept. Even English is my second language, so it helps me a lot. So now we got peers, computers talking to each other, not centralized server. Where there is two different kind of peers. Okay, so the peer could be an endorser or it could be a committer. So just think about an endorser, someone who basically check the signatures of the transactions and all that, and then he says, "Okay, I'm just a participant. I just checked some basic stuff. Now I'm gonna give it to you." Now he's gonna give it to another peer, but that peer is not an endorser. His job is now to be a committer, okay? And that committer is the node or the node is the peer that will actually send that to an ordering service, right? So a committer can be basically so endorsing peer, right? It says in here, let me highlight this in here. Every endorsing peer, right, which is this one on the top here, is also a committer, right? But the committer, right, cannot be an endorser. You can go here, it could be both, but this way in here, you cannot be an endorser. It's basically what it's telling you. Let's put an X over here. No. So the endorser could be a committer, but the committer cannot be an endorser, right? So the endorser have a specific function. So what is this gonna do? It's gonna check the client signature, and then it's gonna run a chain code to read and write sets of the word state basically the layer. When it says the word state, it's the layer, which is affected by the transaction. So it's going to check to see, okay, what's going on that with that table on the block and the layer, right? And then from here, once it verifies those basic stuff, it's going to send it to the committer. So what the committer is going to do, it's going to validate the transaction, right? At this point, the transactions are immutable. You cannot basically unhackable. You cannot, it's already like ready to go. And where the committer is going to send that? It's going to send that to an order service, okay? On a blockchain, you can have a few orders, right? Or you can have, or in a ledger, you can have a few orders. Because if you were talking about Hyperledger, a Hyperledger could be a huge network. And everyone is part of the ledger one. Let's say ledger one, the first database, right? But you can have multiple ledgers. But in other ledgers, you may have different peers that do not participate on ledger one, do not participate on the ledger one, right? So what I'm trying to say is, with Hyperledger, because it's centralized, you have control. You have control of this to decide how many orders you want to have, how many peers you want to have, who is the committer, who is the endorser, who is the orderer, right? What the smart contracts can be deployed, in which ledger, because you can have many ledgers or accounting books. Maybe the first four peers to be part of ledger one or book accounting book number one. Then the other four, right? They could be part of the accounting book number two. So the truth is that you have total control of which organizations, which users, which computers, which smart contracts are deployed where. You control all that. And the order is basically the final step. This is the one that's going to basically stamp the transaction to the ledger. So once you do that and you put the transaction on the ledger, and every peer will have a copy of this transaction because it will go on the ledger, then you cannot reverse that. So I hope you like this video. You can do your own research. You can pause the video. You can read this. Okay, it's not a problem. Feel free to keep watching these videos. I'm going to be teaching Hyperledger, Fabric, and then we're going to go. There is many other kinds of Hyperledger frameworks out there. There's one that works for Ethereum, another one that is used for identity, another one that is for just developing smart contracts, and much more. We're going to get into it. But for now, Hyperledger Fabric, components, peers, orderers, different kind of peers, and we go from there. Feel free to subscribe to my playlist. I hope you like the video. Thank you very much. Have a good day.